Welcome back, and thank you for tuning in to Photon Vision at 6, the best physics news at San Diego State. Our next story takes us to the intriguing world of fluorescent light. Many theories have been proposed on exactly how these everyday appliances actually function. Our very own Ms. de Broglie Wavelength is on site to cover this story.
Hi, this is Ms. de Broglie Wavelength reporting to you at home from actually inside a fluorescent light bulb. It's nothing but bright and shiny in here. Recently, physicists, thanks to Tony DeMurrow's genius, have actually discovered how the fluorescent light bulb works. Every time you walk into a room, you can just flip the switch and it turns on, but there are many different components that actually add together to make that light work. No more walking into the kitchen with the late night munchies and letting your mind get clogged with exactly how that fluorescent light bulb above you is working. Physics News at 6 has worked very hard to get inside this light bulb and bring you first-hand news about exactly how that fluorescent light bulb is working. First, what we're going to need to do is go back to the lab where all that research was done and hard work to actually discover this new phenomenon, to explain to you exactly how the fluorescent light bulb works before we bring it to you firsthand on this nightly news.
Hello, I'm Dr. Pinsel.
And I'm Dr. Anderson.
And I'm Dr. Prieto.
We're going to explain to you how the fluorescent light works. Here is a diagram of inside the fluorescent light. We have a fluorescent light tube with mercury vapor inside. First, once someone turns on the light switch, the voltage creates a lot of electrical energy, which excites the electrons. In the tube, the electrical energy excites electrons in the mercury atom here and causes it to move up in orbital, and when it relaxes, it moves back down in orbital and releases a UV photon. This is not yet visible light because it has a different wavelength than a visible light.
After all this has occurred, a photon goes towards the glass and it gets closer to the phosphorus atom. This then excites an electron, which then moves up in orbital and it releases the visible light. The electron accelerates up and down until finally it releases an electromagnetic radiation, which is a wave. All the photons inside have the exact same energy. As you can tell, fluorescent and incandescent lights are extremely different because the fluorescent light has a whitish glow that it gives off, and an incandescent light has a yellow light.
Alright, thanks to the scientists for that good explanation of exactly what occurs. We're back inside the fluorescent light bulb to see firsthand what happens to each of those atoms that was just explained to you. Brace yourself, you're about to witness one of the world's greatest phenomena known to man that we've discovered yet. What occurs first, as Dr. Pinsel explained, is someone would walk into a room and turn on the light switch. What that's going to do is induce voltage in that fluorescent light bulb, and this is exactly what's going to occur after that happens.
Wow, all that voltage just made me really excited. I'm a maniac on the floor, and I'm dancing like I've never danced before. I'm excited.
Wow, seeing him get so excited makes me get excited too. Now I'm going to jump up in orbital.
That's my cue!
Wow, that was one excited mercury atom. But the real reason that we can't see that UV photon that popped out is because it's a different wavelength than visible light. The UV wavelength is around 400 nanometers. And when we talk wavelength, we're meaning from one shroud to one crest of the actual wave. Each type of light has a different wavelength, and because UV light is a different wavelength than visible light, we can't actually see it. So at this point in the fluorescent light bulb, no visible light has been emitted. Visible light is around 700 to 400 nanometers. And depending on the color, it can change the different wavelengths as well. But because UV light is a different wavelength than visible, we don't see anything. So now that the UV photon has been emitted, we're going to see what happens next in order to get that visible light known as fluorescent light.
Now that I'm released, I'm going to travel on over to the phosphorus atom.
Wow, that makes me really excited too. Seeing the phosphorus atom get really excited makes me get excited too, and I'm going to jump up another orbital. After jumping up here, I'm really exhausted, so I'm just going to relax back on over here.
Wow, it took all that just to create the light that we see in any given room with a fluorescent light. The wavelengths of this visible light are traveling at the constant speed of light, which is the same for all wavelengths, which is really fast at 3.0 times 10 to the 8th meters per second. The light we've seen it is a mixture of many different wavelengths, and that same type of light is given off by the sun as well. It's not just one single wavelength given off, but a mixture of a lot. In order to get what we call monochromatic light, which is light that only has a very small discrepancy in wavelength, which would be like 500 to 501 nanometers, we have to use certain filters in order to do that. And visible light is only one small part of the electromagnetic spectrum. There are many other types of light, including UV, gamma, and X-rays as well. And the closest we can get to monochromatic light is when you use such things as a laser. It's not perfect, but it's the closest that we can get. So this visible light given off by all that we've seen in this fluorescent light bulb is just a mixture of many different wavelengths that we can see with the naked eye. All that excitement in those two atoms has definitely worn me out, so I guess we'll send it back to the studio with Ron Burgundy.
Thank you, DeBroglie. Wow, that's incredible. Well, that's all the news for now. Thank you for tuning in to Physics News at 6, San Diego State's best physics news. I'm Ron Burgundy. You stay classy, San Diego State. Great show, everyone. Top notch, really. Somebody just get me a scotch now, please.